morning, 7th grade. We are looking at our first lesson in our new chapter. So we are going to be looking at electricity in this chapter. So our first lesson is electric charge and static electricity. So first of all, let's read about force fields. Misconception, singular. Force fields exist only in science fiction stories. Fact. Force fields are an important part of your everyday life. You're actually sitting in a force field right now. A force exists around any object that repels or attracts other objects. A giant gravitational force field surrounds the Earth. This field keeps you from floating off into space. Earth's magnetic field makes compass needles point north. You make your own force field every time you get shocked when you reach for a doorknob. I'm just going to show you the picture because it's from Fantastic Four, and I really appreciate it. You can see it. So, a gravitational field keeps you on Earth. What other uses might force fields have? Just a question to think about there on your own. So, 2 key questions today. First, how do charges interact? Second, how does a charge build up? So, we have atoms. They contain charged particles called electrons and protons. If 2 electrons come close together, they push each other apart. 2 protons behave the same way. Protons attract electrons because the 2 have opposite electric charges. The charge on a proton is positive, plus. The charge on an electron is negative, minus. Charges that are the same repel each other. Charges that are different attract each other. Now this should sound familiar to you because they behave the same way that magnets do. If the magnets have the same poles, they're going to repel each other, and if they have different poles, they're going to attract each other. Okay, the interaction between electric charges is called electricity. An electric force is the force between charged objects. An electric field is a region around a charged object where the object's electric force is exerted on other charged objects. These electric fields and forces get weaker the farther away they are from the charge. An electric field is invisible, so you can't see it. Single charges have straight field lines. Multiple charges have more complicated field lines. That should also sound familiar because that's how magnetic fields work. Static electricity is the buildup of charges on an object. In static electricity, charges build up on an object, but they do not flow continuously. We have conservation of a charge. Charges are neither created nor destroyed. So an object can't become charged by destroying or creating its own electrons. If one object loses electrons, another object must pick them up. So the charges don't go away, but they just maybe get passed from one object to another. Okay? So, remove my bubble. There are 4 methods by which charges can redistribute themselves to build up static electricity. By friction, by conduction, by induction, and by polarization. So we're going to learn about all of these. So friction is the transfer of electrons from one uncharged object to another by rubbing the objects together. So charging by friction. When 2 uncharged objects are rubbed together, some electrons from one object can move on to the other object. The object that gains electrons becomes negatively charged. The object that loses electrons becomes positively charged. And then charging by friction we just read about. Number 2, conduction is the transfer of electrons from one object to another by direct contact. So you can see in the picture she's touching something that has an electric charge. So when a charged object touches another object, electrons can be transferred. Electrons transfer from the object that has more negative charge to the object that has more positive charge. A positively charged object, like the metal ball that she's touching, gains electrons when an uncharged person touches it. The girl starts out neutral, but electrons move from her hair through her arm to the ball. This leaves her hair positively charged and the strands repel each other. Okay? Number 3, induction. a method of redistributing the charge on an object by means of the electric field of another object. The objects have no direct contact. So electrons can react to the electric field of a charged object without touching the object itself. In some materials, like metals, electrons can easily leave their atoms. When a metal object is close to a negatively charged object, electrons are repelled by the field and move away from it. The close end of the metal object becomes positively charged, and the far end becomes negatively charged. The opposite happens if the other object is positively charged. This process is called induction. And finally, we have polarization. The electrons react to electric fields, resulting in individual atoms having charged ends that are attracted to charged objects. So in other materials, like the bits of paper in this photo, right here, electrons move only within their own atoms. The electrons react to electric fields, resulting in individual atoms having charged ends that are attracted to charged objects. This is called polarization. Charges don't transfer between objects in polarization or induction, so neither method changes the overall charge of objects. Parts of objects end up charged in opposite ways. Static discharge is the loss of static electricity as electric charges transfer from one object to another. It often produces a spark. It's typically more frequent during the winter because objects hold on to charge better in dry air, usually really dry in the winter. And then lightning bolts are an example. So let's look at our vocabulary. Electric force is the force between charged objects. Electric field, a region around a charged object where the object's electric force is exerted on other charged objects. Static electricity, buildup of charges on an object. Conservation of charge, charges are neither created nor destroyed. Friction, the transfer of electrons from one uncharged object to another by rubbing the objects together. Conduction, the transfer of electrons from one object to another by direct contact. Induction, a method of redistributing the charge on an object by means of the electric field of another object. The objects have no direct contact. Polarization, the electrons react to electric fields, resulting in individual atoms having charged ends that are attracted to charged objects. Then we'll have to go back for static discharge, is the loss of static electricity as electric charges transfer from one object to another. And your assignment is to complete the Ed Modal questions for lesson 1. If you have any questions, please let me know.